should be good to go, Kelly.
Okay. Good morning. As I was introduced, my name is Kelly Powell. Today I want to talk about compressed gas management, leak detection, correction, and achieving reliability. And the real focus today, any operation, is the key word is achieving reliability. The thing is that, we do work throughout the world. And the thing is that today, one of the big things I'll be talking about is leakage. And to walk into facilities and there are 300 leaks is totally unacceptable today. I go to Thailand. I'll be leaving here probably in 3 weeks. And I go to a chemical plant. The chemical plant's about 6 miles long, and their leak levels is below 10 leaks on their compressed gas system per year. But they've gone through changes so they do not have leakage. So I'll talk a little bit about that. The thing, this topics of discussion is how to conduct a successful compressed gas leak detection program, correction, management. What is the correct equipment to be using to detect leakage today? Collecting leakage points, data on leakage points. One of the things is going out and doing a compressed gas leakage assessment is collecting all the information required to analyze the leak points. Now, I'll talk a little bit about that. Component failures and a little bit into accountability. Today requires reliability. What is life expectancy? When we go purchase a component, do you ask the vendor, what's the life expectancy? 1 year, 3 years, 6 years, 15 years? So when we're doing projects, and we just completed several major projects for the 4th of July shutdown, one of the things that, in the interviews with the equipment manufacturers, what is the life expectancy? If you come back and tell me 1 year, that's life expectancy. And then people say, well, it should last longer than that. I don't use the word should, because I should win the lotto on Saturday night and then I'm done. So I don't use the word should. But there are, components out there 15 years, that for life expectancy. Now, the point is that I can go out and buy a component that's just going to last for a year. It's going to be a lot cheaper. Really is. I mean, I only have to make it to last 1 year, 1 day, which is the warranty period. Otherwise, I can go out and purchase components that last 15 years. So the thing about that is that evaluate the life expectancy. Yes, 1 year is going to be a lot cheaper. But the other thing is you can see here in this picture here, is going out and fixing leaks, on the actuator and the fitting. That costs me money. The other thing is root cause analysis always has to be part of the project. If a component failed, why? I need to know why, So that's part of the program also. So, change needs to achieve positive reliability results. Results does not equal no results plus a good story. The thing about it is that we have to change. What we did 15 years ago is not what we do today. And people ask me, what do you mean by that? One thing is we don't thread pipe anymore. We give up threading pipe a long time ago because in any leakage assessment, threaded connections is the #1 leak point. And you can, go into how to properly put in threaded connections, and everybody's got an opinion. You ask 10 different people, you get 10 different, methods of putting in threaded pipe. The thing is that there are alternatives today to threaded. So, we'll talk about that. The thing is, if we don't change what we're doing, then we can't have positive reliability results. So, what the changes that need to occur? Yeah, root cause analysis has to be part of the program. So a component fails today, analyze it, determine why it failed, make changes to, example, component purchasing. A huge assessment we just did for a pharmaceutical out east. We found a specific filter. It was, if we surveyed 30 of them, 20 of them were in failure mode. So we eliminated them from the purchasing documents, so they could no longer be purchased. Engineering specifications. So we come in changing engineering specifications. One of the other things that has a high failure rate is standard valves, which are Golden Gate valves. When's the last great revolution we added a gate valve? Was 1941. There's nothing new. For one thing, is people buy them by price. So they engineer them to be more cost effective than instead of engineering for reliability. So changing engineering. Installation. One of the things is putting in tubing, piping, supports. Those things need to have the correct layouts. Operation, make sure that the operation's proper. Now people are not starting up too fast, causing issues, and selection process. And the big thing is accept no failures today. Just don't accept failure. I just don't accept failures. If something fails within, like compressed air, if something fails within 25 years, I find that totally unacceptable. There's no reason to have failures on compressed air. It's an easy gas to work with, the easiest gas to work with. The other thing is safety is always number one in any program. And, we know we have to be looking at the codes and ASME pressure vessel, B31.1, B31.3, and B31.9. So when we're putting in compressed gases, we need to know the codes. So these are probably the major codes we're looking at. If we follow the code, no safety issues. We follow the code, we make sure that everything is going to work without causing any failure or safety issue to the plant personnel. So always, make sure you're aware of the codes and follow the codes when installing the compressed gas systems. The other thing is excuse me, a little touchy here. Sorry. The thing about, just take for example, compressed air. If we're having 300 leaks, we can calculate how many pounds of CO2 that is per year, pounds of NOx, and pounds of SO2. The thing is that the software today allows us to make those calculations. Therefore, you can go to environmental and say, hey, if we fix all this leakage, we're going to reduce CO2, NOx, SO2. And you say, how do we do that? Is by removing electrical load, which is coming from the power station. Those calculations are based on that. And that information comes from the EPA. The other thing is compressed gas is used in all types of industries. Almost every industry walks into electrical and power generation, rubber products. We just finished up a project for a tire plant that was producing 40,000 tires a day. That's a lot of presses, and all those presses use compressed air, nitrogen in the system. So there's gazillion miles of tubing and connections and stuff like that. And pulp and paper production, food processing, pharmaceutical refinery, chemical product, and the list goes on. Hospitals. We use compressed gases in all types of industries. In order to improve reliability, reduce downtime, increase production, and reduce energy, it's necessary to evaluate, understand each component of the system. And the thing about we look at that is we look at the total system. And I'll give you an example. So I come into a plant, and the thing is that I go out and fix. Okay, let me step back. I come into a plant and there's 4 air compressors running, and I go out and fix 200 compressed air leaks. Did I save any money? Not if 4 air compressors are still running. So you have to look at a system. So we come in and say we're going to do compressed air leakage and correction. The intent is to shut compressors down, air compressors down. So if we don't do that, brake horsepower between our air compressor unloaded and loaded is a small percentage. You have to go and shut compressors down. And that's our objective anytime we go and do compressed air leakage assessment. The distribution system is doing the proper layouts, support, engineering and correct designs. One of the things that we do is we stay totally away from plastic tubing. It's just going to people. The thing is that it's all right with plastic tubing if people are not around. If people are around, they can abuse it. They're going to abuse it. One of the things that we do in distribution system is up in the ceiling areas or top of the building or whatever, there's no leakage. Why? Because people are not up there. Whereas the leakage is where people are working around the lines. They'll step on lines, they'll run into compressed gas lines. They do all kinds of things. So we want to make sure that the lines are protected and well laid out. And the other thing about engineering and correct designs, anything that requires maintenance has to be at floor level or platform level. Don't put anything up in the air or up in the ceiling area where people have to get lifts and everything to get up there because they're not going to get up there. So on our distribution lines, we are welded, flanged, two connectors, anything that guarantees not to leak. And then, so we don't have to worry about leakage up there. The other thing is labeling, coming in and properly labeling all the components, so we know we're dealing with nitrogen, argon, or the different gases. The other thing is, when we look at distribution, is maintaining compressed air quality. And there's been papers written about leakage will degrade the compressed air quality, and that is correct. And the other thing that we're doing is distributing long distances, and we can just distribute gases high or low pressures. That's not a problem. So the assessment points, the thing is what you want to do is list out the major failure point and then define subgroup and analyze the data. So the thing is that when we come and say a major failure point is connection, and then the subgroup would be threaded connection, flange, tube connector, etc. And then we can even break it down from that. The thing with that is that we can analyze what's going on. Instead of just having connection doesn't mean anything to me. I have to sub-analyze it to see, okay, I had connections, NPT, threaded connections, made up 85% of my failure points. Okay, so then I need to take corrective action on it. How are they installing it? Is there alternative to the threaded connections that we can get away? Another one, we working at this pharmaceutical plant, we found that the tube connectors were leaking. Well, the tube connectors were leaking because the people were not installing per the manufacturer specification. So we said, okay, that's cause of the leakage. So let's institute training so the people that are putting in the tube connectors are aware of how to do it correctly. The other thing is coming up with the energy losses. The most important thing that probably comes up is cost to implement corrections. I used to be in charge of a power plant in my younger career. And people come in and say, hey, if you put this in or do this, it'll save you $250,000 a year. Great. How much is it going to cost me to implement this? If it's going to be $6 million, it's not going to happen. So any assessment is that, yes, the energy losses, but you also have to have cost to, make those corrections. And that's a big factor. Because if I go up and submit, I'm meeting the project, yes, I need to know the energy losses, but also need to know the cost to implement all these corrections. Connections, there will be the highest number of failure points. And I've done assessments in North America, and I've done in, Australia and Singapore, all over. Threaded connections are number one. Or connections are number one for any leak point, and then the subgroup is NPT. That's the highest. They'll make up any assessment we've done. Probably 65 to 70% is going to be NPT connections. Just amazing. And I've seen it, throughout the world, and I've seen so many thousands and thousands of different ways people are trying to stop leakage, Teflon tape, and blue sealant, purple sealant, and everything else, and they still are achieving leakage. So the thing is that to get away from it, we'll try to eliminate NPT connections. We have the technology to do it today. So the other types of connections is, of course, like shown here is a union, tube fittings, very low. Flanges, people say to me, flanges leak. Flanges do not leak. Today, when you put flanges in, you'd have to know the torque spec and the torque pattern, because the gasket materials today, you can extrude them out. So when you go up and put a flange in, you have to know the torque spec and the torque pattern. The other thing is that the flange only takes axial movement. If you have anything outside of axial movement, you have to guide the pipe. So, the flange is only accepting axial movement. With that, a flange will last 50 years without leaking. They just do not leak. So. The other, to eliminate connection failures, welding, of course, flanges, and industrial design tube connections. When I say that is, there's a lot of different selections in tube connectors. Today, I can go into Ace Hardware and get a tube connector. That's not even good for my house, but anyway, there are industrial designs, so make sure you're using industrial design. Eliminate thread connections, and the other thing is that high failure rate is these push type connectors. So I just find over and over they have high failure rate, and they don't really take abuse. And if you insert them one time, that's great, but if you're disconnecting and reconnecting, they just have a high failure rate. So I try to, any of our projects, we don't use push type connections. So, The second largest failure point is valves. And the subgroup is packing on standard pack type valves. Get into it, and people say, we use this gate valve or whatever. But I go back and look at the technology changes in valves. And one of the things is that, I'm serious, the last great revolution we had a gate valve was 1941. And I don't use old technology. I use new technology in everything I do. It's no different than my personal life. I have an iPhone X, which is the latest and greatest because, I want that. But the thing with valves is you get the top, gaskets are leaking, the packing leakage. And the other thing is internal leakage. When you're buying valves, you have to specify internal leakage. I'm on a job site in a pharmaceutical. We were just this morning trying to do a shutdown. We shut 3 valves off. We can't get the system to shut down because of the internal leakage. So when you're buying valves today, make sure that the internal leakage meets FCI standard class 4 or API standards. So use newer technology, ball valves, butterfly. I'm big on ball valves. The thing is that ball valve technology has accelerated in the last 20 years. And the internal leak rate is class 6 or higher. So, I mean, when you go shut a valve off, it will shut off. The other thing I do a lot with is on the larger valves, 8, 10 inch. I use butterfly valves all the way up to 32 inches in diameter. Just make sure they're high performance or triple offside type valves. But here's my back valve. So, no, that does not meet any code, by the way. So, insulation, access to all components. So as you can see in here, all the colors down here at this level, floor level. Why? So we can get access to them and maintain and make checks and everything else. If you put something way up here that we need ladders or extension ladders to get to, it's just not going to get maintained. So when we're designing systems and everything else, we're looking at maintenance to make sure the thing is going to work properly. So we always make sure we have it where people can access it. And that cuts down. You can check for leakage and everything. This is a older system and stuff like that. So again, access to it. This is a new compressed air system. The dryer system to be put in. All these valves are butterfly valves, high performance. Dryers today, the desiccant dryers are fantastic. External blower purge designs, tremendous technology. But anyway, the other thing is planning and compressed gas leak detection assessment program. What you want to do is a complete review of the system from the compressed gas generation or the tank system where you could be getting the nitrogen argon from, and leak detection, and of course root cause analysis and the correction program. What methods will be used to accomplish the goal? Use in-house staff. The thing is that people are experienced personnel. They know the plant layouts. They know the safety issues or safety requirements, everything else. So in-house staff, it really works well. The negatives is, you got to have the equipment, cost of equipment. And the other thing is knowledge of leak detection methods. Now, is it a lot of training? You have to get this knowledge of leak detection? No, but you have to have knowledge of the leak detection to make sure the people are doing it correctly. Outsourcing leak assessments, choosing the correct qualifications, the people qualified. Just because they have a liquid surfactant for going and finding leaks, do they really know, how to utilize it, or high frequency ultrasound? I always ask people what's your SOP, standard operating procedure for doing the work. Right now I have non-destructive testing people on site, and the first thing I asked them, show me your SOP for doing the work. They did. I knew they were qualified. And the other thing is certification. So I asked the NDT person if they were certified to level 1, 2, or 3. They said level 2 meets my requirements. And of course, insurance requirements today for the students, that they have the liability insurance and the professional insurance. The one thing is have a detailed RFQ, what you want accomplished. And the other thing is that leakage levels. How small of a leak do you want them to detect and put in the report? And we can find leak levels 1 times 10 to the minus 4. If I walk in a plant to document all these levels of 1 times 10 to the minus 4, you're going to be fixing minute leaks that really do not matter. So we always want to determine what leakage level that we should be looking at. Has a firm done this type of work before in your sector and they have references? I'm not so much on references, but I want to know that they do the work. The other thing is that alternative motive for, for doing the survey. Compressor people like to do this so they can sell more compressors and other equipment. So, and I want people involved with organizations and, working toward energy efficiency. We belong to the Natural Gas Association. I belong to the Department of Energy, different committees and everything else. As I do in Finland and other countries, I want to be part of helping people, reduce energy. One of the things is that I always want to do in leakage assessment, get everybody involved. The biggest thing, if I'm doing for compressed air, is right here, eliminating one or more gas compressors. So I've been in plants that have 10 air compressors in operation. We removed 3 of them from operation. There was a lot of leakage in that plant, but that is your objective and goal. Understand the system needs and requirements and determine gas pressure requirements for each system. I always find people say, what compressed air pressure are you running? 120 psi. My next question, why? There's nothing really out there that requires 120 psi. Every time I get an analysis of compressed air systems, there's no reason to run high pressure, but everybody thinks that they need to. And they say, well, we lose air pressure down here at this point because you use a self-contained regulator that has a droop factor, and nobody knows what the droop factor is. And that goes in a whole different story, but anyway. Benchmark the different components of the system, know what works, what doesn't work, and compare different types of connection with leakage rates, determines project costs, and documented the lower the cost of producer by the compressed gases. There's a tremendous money can be saved by not having leakage. You specify a problem or issue, clear focus on the end results, and 3 major objectives or goals for the program. So I always want to know the 3. What do you want for the end result? Not 100, just 3. Selling program, the management, obtaining the money for the project. We have to get the money budgeted and approved, knowing the costs of the compressed gases, the objectives and goals clearly defined, roadmap, how we're going to get it, and define the results of the program once we're done, and clearly explain the program, how it's going to continue. It's not a once-through program. It's a continuous program. So, determine the equipment to be used for leak detection. There's 3 ways. Human ear to find the leakage, liquids or surfactants, and ultrasound. So we'll talk a little bit about that. We already talked about the degree of leakage and what degree of leakage will not be corrected. Documentation, equipment, failure points, subgroups, and tagging. Because the thing about it is that if I find a leak over here, I have to get the pipe fitters, the maintenance people, or whatever, to find that leak within 5 to 10 minutes. So instead of them looking for 45 minutes to an hour to find a leak point. So, we have used GPS and a multitude of things to make sure that you can easily define a leak point. Today we're using not only very detailed log sheets, but we're also adding pictures of each leak point in the report so they can easily go back and find a point. Benchmark the system, we already talked about, document the results, calculate the energy savings, and then determine product quality and resolve any issues with the plant. So this is just a chart on leakage, and based on X dollars per kilowatt. But 3/32 leak can cost you $1,674 a year. So you take that times 200 leaks, it gets to be a sizable amount of money. So a little bit on the equipment for compressed leak detection. Visual, you said why visual? Once you start the leak assessment, you see a particular filter that if the ones you check are leaking, then you just automatically go to that. Threaded connections, like stainless steel threaded connections, is huge. So, also hearing is, you can hear the leaks. The liquid method, which is the surfactant, is very good. I come into the facilities and we have large quantities of Snoop solution to be able to confirm the leak points. The last one is high frequency ultrasound. Use all methods to be successful. Because I can come in here with high frequency ultrasound, find a leak 60 feet away. Visual. Like I said, I always go for stainless steel connections because they're always very difficult to get the stainless steel threads to seal. The other one's low cost regulators. They're always leaking. And of course, hearing. So, liquid bubble testing confirms leakage point. As you can see, they're applying the Snoop solution to the leakage point just to confirm that the point that they were detected by using high frequency ultrasound. It confirms that they did find and pinpoints a leak also. So very fast and accurate. People here, this person here is geared to do this assessment, can cover quite a large territory with that. There are a lot of different ultrasounds. I always like the ones that are look between 20 and 100 kilohertz. The human ear only hears up to 20 kilohertz. These are looking up to 100 kilohertz above the human ear. So that gives us the ability to pinpoint a leak. High frequencies have characteristics that work different than low frequency. You can, one thing is it's very directional, so you can pinpoint the leak, and you're not affected by machinery sound because you can hear machinery sound. So, ultrasound has multiple planned inspection operations, detects turbulent flow, short learning curve to be very proficient. It doesn't take much training, but you still need to be trained how to use the equipment properly, so you can work. Displays on screen with the test data. We use what we call dB levels. We put that into the software system, and then calculates out the leak size and the amount of leakage. And we can also record the sound inside. Sensitivity up here, dials, we can make the unit very sensitive, find leak levels 1 times 10 to the minus 4, or desensitize it, to determine the leak point. The other one, large gross leaks, we can adjust the sensitivity to pinpoint exactly where the leak is coming from. Using high frequency ultrasound, the person out here is using technology right here. Is he's using his hand to block out a competing ultrasound so he can pinpoint the leakage. And you can see their gear specifically for doing the job with all the safety equipment and all the equipment they need to it. Which means when you're going to do this, be prepared. Successful programs, working in teams. This is the team here. This happens to be in Australia. This is the plant team, extremely large liquefied natural gas. But as you can see, gloves, steel-toed boots, FRs, high visibility, hard hats, hearing protection, everything that you need to do the job. So having the correct safety equipment, a very detailed SOP, which was about 62 pages long, having the correct equipment, and the correct documentation. With all this, you get a positive end result. So, and thank you for your time, and I will take questions if there are any.
Yeah, let me, thank you, Kelly. Let me go ahead and unmute everyone real quick, and if they have questions, they're welcome to ask them now. Okay, unmute all. Okay, yeah, if anyone has questions, feel free to jump in.
Sounds like there's no questions. Okay.
Yep.
Very good. Anyway, if you have any questions, contact, your local Swagelok salesperson, and they can get in touch with me. If we can be of service, any, assessments, product equipment, or anything like that, please contact us, and have a great day.